Let's take an example of the composite pattern in order to really understand it well. And we'll talk about Swing containers. Swing is a framework in Java which allows us to develop user interfaces very quickly. It has a whole number of classes, helper methods, libraries which interact with each other and allows you to plug in listener code at the right portions in order to build up a really slick UI and very fast in record time. UI containers in general and Swing containers specifically epitomize the composite pattern. So it's a good example of how it works. Let's go on and see this. Now, each UI application that you build using Swing has a single JFrame. JFrame is the class which serves as a container for all the UI elements that are present in Swing. So a JFrame can contain many UI elements. Each UI element derives from the same base class, so that there are a lot of common functionality built into that class. So each UI element is a J component. Now there are several examples of J components. In fact, almost all UI elements are J components, such as the J text area, the J tree view, the J menu bar, which gives you the menu options at the top, the J scroll pane, which allows you to build scrollable containers, the J panel, the J file chooser, which is basically the file open and save dialog. These J component objects, the UI elements, fire events that the program listens on and handle as needed. So the entire base class implementation of the J component has a lot of standard shared code which is able to handle these events and allows the UI application to listen on these. Now, the Swing application as a whole has a tree of these J component objects. So you can have a button within a panel, a text area within a panel and then a scroll pane inside it, and then a text area inside that. So the Swing application as a whole has this tree of J component objects or the UI elements. As you can see, these J components can have any number of children. All the children of J components tend to be J component objects. So you notice this tree structure building up, which we saw as a part of the last class. They all inherit from J component and contain more J components. As a user, you'll interact with the root of the tree, which is the container as a whole, or any of the individual J component objects. So you could interact with the scroll pane and a button which is inside the scroll pane. So you interact with the root of the tree as a whole or with individual components. You can do both. What I just described to you is pretty much the definition of the composite pattern. Let's now look at a different example of the composite pattern in action, and that is animations. Animations are a way to add special effects to your UI in order to make it look lively and kind of interesting and engaging. JavaFX as a framework offers excellent tools to support animations of your UI controls. This animation support in JavaFX is also built using composition. In fact, it forms a core component. So it's worth a while to take a detour into JavaFX animations and see how they follow the composite pattern. So, what is animation? If you do a quick search, this is the definition that you'll come up with. So it's got two. We'll focus on the second one for now. JavaFX offers excellent support for animation. The whole idea of animation is that you have a whole bunch of still frames, one after the other, where the position of an object in each frame is a little different. And then you create an illusion of movement when the film is shown as a sequence. This is a great tool for user interfaces. It'll help make them animated. You can add a lot of life and vigor to your tool, make it lively if you have animations within them. It's kind of more interesting to interact with a UI which has some degree of animation. Of course, you don't want to do too much. Let's take a look at the class hierarchy in JavaFX animations. We start with the animation class at the very top of this hierarchy. It's an abstract class called animation, which lies at the core of JavaFX animation support. Any animation that you develop within JavaFX inherits from this class. Now, all animations in JavaFX have some core properties and some core behavior. All animations can be played, paused, and have a playing time, which is the duration of the animation. This is common to all animations. In addition, animations can also be sped up, slowed down, or made to play back and forth. So these are all the operations that you can do on all animations, whether it's the built-in JavaFX types or the ones that you create. Now, the animation class is abstract. That is, it cannot be instantiated directly. So you can't create an instance of just animation. But there are two types of animations which you can create and instantiate. Let's take a look at what they are. The first type that we look at is something called timeline animations. And the second is called transition animations. These are the two types of animations that you can build using JavaFX. Since timeline and transitions are both animations, there exist some similarities and differences. Both timeline and transition animations take some property of the object that they are animating and change it in a predictable manner. So say you're animating text or a square or a rectangle, you take one property of that and then you transform it in some predictable way. So this is the similarity between timeline and transition animations. Now, transition animations are those which are pre-packaged by JavaFX for the most common use cases. If you think about animations, there are some things you'll do more often than others. For example, fading something in or out, translating something from place A to place B. Common transitions, which are used the most often, are pre-packaged by JavaFX, and those are transition animations. Timeline animations are the ones you define. They're completely user-defined and are custom animations. Let's look at some of the common animations which JavaFX offers us. These are all transition animations. Fill transition, to fill a shape with color. Fade transition, to fade a shape or a text element. Path transition, to translate the path of something. Or sequential transition, which is to play transitions one after the other in a sequence. Now that we've understood transitions in JavaFX, it's important to know that they're usually built up using the composite pattern. If you notice, there are a whole bunch of transitions, which means a whole bunch of objects very like each other. So let's see how we can build up transitions using the composite pattern. Let's look at all the transition animations, which are a bunch of transition classes which are pre-implemented by Java and available as a part of the JavaFX library. There are a whole number of these and they're kind of classified in different groups. Let's look at them quickly. So we have the fill transition, the fade transition, and the stroke transition. After that, we have the rotate, scale, and translate transition. Then we have something called the path transition, and then a pause transition. The rotate, scale, and translate transitions rotate, that is, turn on an axis, move or scale a node. A node is effectively any UI control. It can be a shape, it can be text, anything. So that is what these transitions alter, the single property that they alter. They effectively alter the size, orientation, and position of a node. The path transition is kind of an interesting one. Given a node and a path, that is a set of points, it will move the node along that path. So it can kind of be used to trace an outline of something. That is the path transition. The fill, fade, and stroke transitions, they provide fill, fade, and outline effects on any node. So you need to give it a start and end values, start and end value of opacity, for example, a duration, and they will operate on the fill, opacity, and stroke properties. So you have the start and end values of each and the time it takes to go from the start to end. And these transitions operate on those properties. And lastly, we have the pause transition, which is basically just that, a pause. It's effectively a do nothing transition. You pause for that duration. Now, it's important to remember here that transition classes operate on specific properties of some object. If you look at all the examples that we just saw, they take one property and operate on that to change its value from some start to the end. If you take the fade transition as an example, it always modulates the opacity of an object. So you give the start opacity at which the object starts and the end, and for the duration of the transition, it changes the opacity from start to end. This is awesome, right? It's a great way, a great logical unit. It's very handy, but sometimes a little bit constraining. Because if you think about animations, they are not always this simple. You want to be able to build up to more complicated effects. So how do you do that? Aha! The hero of this course, the composite pattern, to the rescue. This is the point where we want more complicated effects, and a way to bring these transitions together is where the composite pattern comes in. So there are two specific transitions which JavaFX provides: sequential transition and parallel transitions. These don't operate on any one property of an object. They are pre-packaged JavaFX offered transitions, but they are not the same as the others, though they still derive from animation. So they are the same type of object. Sequential and parallel transitions are meta transitions which place several other transitions either in series, in a sequence one after the other, or in parallel, all at once. So say you've defined 5 transitions which basically change the shape of an object, rotate it, fade, have a stroke property. Sequential and parallel transitions will allow you to have all these effects played together or in a sequence. By chaining together transitions either sequentially or parallelly, we can achieve surprisingly complicated animated effects. And the way you deal with a sequential or a parallel transition is exactly like how you deal with the transitions individually. There is absolutely no difference. So you might want a transition which stands alone, then a sequential one, and then a parallel one, and you deal with them all the same, because at the heart, they are all animation objects.